everyone. My name is Erin Winnick Anthony. I am the onboard outreach officer for Expedition 401 on board the JOIDES Resolution. So I'm going to start out by just showing you this map behind me, which doesn't look like much from far away, but up close you'll see there are a bunch of dots on this map here. And all of these dots represent places that we've taken cores of the ocean floor over the past 5 decades. And I wonder, why are we taking these rocks from beneath the ocean floor? Well, it's for science and studying a number of different things. So first of all, we're looking at the history of Earth. We're looking at anything from dinosaur extinction to the origins of life on Earth and so much more. So for our expedition, I'll show you, we are Expedition 401 up there. And so what we are studying is something known as the Messinian salinity crisis. And this is a period around 5 to 8 million years ago when the Mediterranean and the Atlantic were cut off from each other. So these two are very important bodies of water. But when they got cut off, this caused a lot of the water in the Mediterranean to largely dry up, leaving behind around a 1,500 meter thick layer of salt. This is known as a salt giant, and this had a huge impact on the Earth's oceans, the circulation, the chemistry, and Earth's climate. So that's what we're looking into with our course. And right now, we actually just today went into the Mediterranean for the first time on our expedition. It was super exciting. We sailed through the Strait of Gibraltar, which is the connection point today between the Mediterranean and the Atlantic. So we all got up very early to go see that as we were going through. Super, super fun. We actually started, though, I'll show you real quick, up in Amsterdam. Went along the coast of Portugal and Spain, and that's where we were for the first about 6 weeks of our expedition. And now we'll spend the remaining like 2.5, 3 weeks here in the Mediterranean, which we're all very excited about. So without any further ado, I'm going to take you on a tour around the ship. So we're going to start by heading up to the bridge. Then we're going to see the large drill derrick that we use for the technology for the coring. Then we're going to go into the lab, and we're going to have an opportunity to do some Q&A with scientists on board at the end too. And today we're going to actually have Shamar, who's going to be helping us, and she has a bit of background in oceanography as well. So although that's not what she's doing on board, we're happy to take questions for any of those areas. So super excited. And just a heads up, we're a little bit later time period than you all are in Hawaii. So we're actually going to be dark outside when I go out. So I'll try to get you some quick views of waves out there, but we're a little after 9 o'clock here. So won't be as bright and beautiful as your background. So start out, we're going to go out this very ship-looking watertight door, and we're going to head up to the bridge. And a heads up, there might be a few periods where it's a little noisy, but I'll make sure to pause and talk to you after we get past the noisy spot. As we are walking, you'll see over here is some lifeboats. They might look a little different than you're used to lifeboats looking like. They are large orange things that are encapsulated on all sides. We can fit up to 70 people in these. We only have 35 people assigned to each one on the ship for safety reasons. So we have backups in case something goes wrong. But we actually have trainings every single week. Make sure we know where to go, how to stay safe in case of any emergency. So let me see if I can get you a quick water view. So you can see some of our waves. It's a little bit windy out there. So I'm on the less windy side of the ship to be able to show you around a little bit more. And in the distance, there's a few lights that you can see on some of the ships going by. I'm not sure if it's able to be picked up. But yeah, all right. So now we're going to head into the bridge, and Frankie is going to show us around a little bit. Hello, how are you doing tonight? All right, so this is Frankie. He's going to show us around the bridge a little bit.
Okay, yeah, welcome to the bridge. This is our bridge, and we navigate the ship here from other places from our side to maybe next side. So we navigate here. This is our steering wheel. It's our engine. We have 2 engines. We have 2 propellers and 2 rudders. Okay. we have here our the daylight, so we can see how big that is. This is our electronic chart display or ECDIS. Here we plan our passage planning, and then we can see where we are going. So yeah,
That's
you see, yeah, that's us. This part here is Europe. The southern part is Africa or Morocco here. And then this green thing here, these are the boats, ships, other vessels. They are, you can see its name already. That is the cruise ship Jean. So yeah,
very
this
cool.
is because of the AIS or the automatic identification system. We know every other ship now. Also, as we can see us also.
Very cool.
And this is our next plan going to Napoli.
Yeah, our next stop will be Italy after this. We'll be here for a little while though.
A while though, yeah, we have to leave here around February 5th, the day, and you can see the red line there. I already have the plan. Going to Italy. There is Italy.
Very cool.
Yes. So yeah, we get 3.5 days to go.
All right, that's awesome.
So this is our radar also. You can also see the other ships here. You can see how they are doing, the speed, and how close they're gonna be to us. This is the closest one, which is about 3 miles. So if you can, we can shut off the lights. If you can see the Spain there already with the city lights, you can see it, 12 miles.
Very cool.
From the nearest land.
You're getting lots of emoji thumbs ups
Oh,
too, okay? And applause, yes. Cool. All right. Well, thank you so much, Frankie. Appreciate it. Great. We got some applause here.
Yeah.
All right, you grab it. All right, Frankie's gonna get the door for me.
Careful out there. Too windy.
All right, appreciate it. Thank you so much. So, big thanks to Frankie. And now we've seen how we're driving the ship and moving around. We're going to go take a look at the technology that allows us to get these cores from underneath the earth. Because while we're here, we don't want to be moving around. We're trying to stay really still to be able to drill and get this core from underneath the ocean floor. So here's what we're doing using to do that. So this is our derrick, and it is around 200 feet above the water line, or 26 elephants tall, which is the comparison that I like to use. So this needs to be tall so that we can prep our drill string to go down to the sea floor. So basically it's a big tube that we hang up here and then are able to lower it down, prep the next section, lower it down. And that's what we're doing right now, because we actually just navigated from our third site through the strait here today. So we're prepping our drill string to go down to the sea floor. And it'll take a few days for us to get ready. And then about 3 days from now, we'll be coring and pulling up that rock. So we'll take a close up look. It might be a little loud when I get nearby, but then I'll talk to you for a second afterwards if it is. And you'll notice I'll cross over this line, which means that's why I'm wearing my hard hat and safety glasses, so it's to be safe when we're around all the big machinery. All right, let's take a look. You'll see some pipe going into the air, I think, actually. I'll give it a second for it to go by so I should be safe myself. So we have a lot of tube on the ship. Honestly, a lot of our storage is used for either this drill string tube or for our core, because we're pulling up kilometers of core during our expedition. That's a lot of rock that we have to figure out what to be able to do with. So that actually goes on the bottom floor of our ship in cold storage to be able to maintain and preserve that rock. So one thing also to mention is thinking about how does the drill go out of the bottom of the ship? Yes, we do have a hole in the bottom of our ship, which might seem like a bad idea, but actually, the way I like to describe it is though our ship is like a big inner tube. If you have an inner tube in a pool, there's a hole in the middle, right? But it still floats. Well, our ship is like a big inner tube with a hole in the middle, and also our lip kind of goes up above the water line, so we're able to maintain and not flood the ship even with the hole in the bottom. And we can close it during any extreme conditions too. All right, so another little peek, you'll see this tube is now getting connected over to where it's going to be lowered down. So then after any core comes out of the floor or right around where those two men are working over there, it's going to come onto our catwalk, which is the first time our scientists see it. So we're going to head down to the catwalk. And what it's going to come up in is these plastic tubes. So these tubes are like basically big straws that we're able to fill with rock, and they are around 10 meters long. So you can see they stretch pretty far along this catwalk. And that might be pretty hard to bring inside and use for science, right? So we lay it out on this big table behind us, and the technicians are able to cut it into segments that are much more manageable to be able to bring inside and use for science. And so after they cut it into those sections, they put caps on either side. I think we actually have one sitting out here. So there'll be a cap on this side, cap on this side. Blue is the top because blue goes towards the sky. That's the easy way to remember that. Then also sitting out here, just as an example, these are actually the drill coring bits that we're using to get that rock from out of the ocean floor. So these are actually flipped upside down when they're working. This is what's going into the rock. You'll notice a major difference between the red and the silver ones. The red doesn't have a hole in the middle, while the silver ones do. So the red one is great if you just want to make a hole and get down to a certain depth quickly. If you want to pull rock up from the ocean floor, you want one with a hole in the middle so you're able to pull that core out. And so through this hole can go a couple of different tools. One of them is called advanced piston coring. And basically this is like a large cookie cutter that can shoot into soft rock about 10 meters. And if you've ever like put a straw into a soda, put your finger on top and hold it out, and all the liquid still stays in there, that's kind of like what we're doing with the softer rock. And then if we get into any hard rock, we have some cutting bits and things that are able to carve into that rock as well. So we've done both of those types of drilling on this expedition so far. And so now that we have all of that rock out of the ground, it's going to go into the lab. So we're going to head inside and see some of the different labs and equipment that the scientists use. Got another big door to open. Okay, so once we're inside, the first stop for the cores is going to be this machine right here, which is our laser engraver. And when it is running, we have a screen here. It is actually over here that has a laser-eyed cat on it who helps us engrave our tubes for us. And then after it's engraved, you put it over on this rack over here. And this is basically where we either let it cool or warm up. We want to get it to room temperature based on whatever temperature it came out of the ground as. You can see we have two kind of like halves over here because after they sit for a while, these tubes are going to get split in half. But before they do that, just quickly, I wanted to show you, this is the physical properties lab over here. So this is actually the first stop for the cores when they're getting scientific measurements taken. So this machine, the core would sit right here. This arm then pushes it along into these different mechanisms. It'll take different measurements. My favorite personally is this one that looks at the magnetics of it. So how magnetic is that rock that we pulled out of the ground? We even look at how sound waves move through the rock, how heat travels through the rock, and the radioactivity of the rock. And that's what the machine over here is able to help us look at. They're not particularly dangerously radioactive. There's just really, really small signals that we can pick up that help us learn more about the rocks that we're pulling out of the ground. And so after they're finished taking those scans and measurements, they're going to go and get split in our splitting room. We're going to go through some magical opening doors here. Ta-da! And so here's where they get cut in here. With the softer rock, we're able to use this sort of wire here that's, if you ever used a wire to cut cheese, it's kind of like that. But then when you get to a harder rock, this is a saw that can run down the full length of the thing and cut it in half. And the reason we want to cut it in half is we have two main things that we're doing in the lab. One is sampling and one is doing a lot of scanning and observation. So the halves will be split. One will come over to this table, one will go over to that table. So here is our working path table, and this is where samples can be taken from the cores. On the wall over here, you can see some of our sampling containers and tools that the scientists will use to store different shaped samples that they pull out. And then the other half won't be disturbed. Basically, it'll be kept in its original form. And that's really important so that we can have it preserved so that future scientists are able to study it in its original form too. It'll be sent to a repository where they'll be stored and scientists can study it forever. And so some of the things that are done with that are there's really, really high definition images that are taken of it using a camera that'll slide down along it. There's color measurements that are taken, grain size measurements, and basically just visual description as well. A lot of notes that our scientists will take really up close looks at any tiny fossils and things like that that they might be seeing in it too. And now the other main thing we care about is how old these rocks are. And I don't know if you can hear in the background, it's had like a heat noise. So that is this machine right here, which is used by our paleomagnetists. So in Earth's history, if you've been using a compass, that north wouldn't have always pointed the same way. In Earth's history, the poles have actually reversed. And this happens over very large time scales, but we know in Earth's history when these reversals happened. So by looking in these cores, when we see a reversal, we can know we've gotten to a certain age, which helps us give us those markers of how far back we've gotten. And then our other group that's helping us look at ages is our micropaleontologist over here. And this is Shamar back here. She's going to join us a little later for answering some questions. So in this lab, we have a bunch of really powerful microscopes that allow us to look at tiny, tiny, tiny fossils. Shamar, do you want to talk a little bit about what you do? So, here.
All right, everyone. I'm Shamar, and here are my colleagues. And we study microfossils. Erica is also a geochemist and sedimentologist, and she's taking fish teeth right now because she can use them for isotope analyses to help us trace water masses, which is something we're really interested in. But as for me right now, these are my smear slides. I take the sediment. And so you think about dinosaurs, right? When you think about paleontology, I study microdinosaurs, just kidding. I study algae. So we see algae in our oceans, they're fossilized, and they've been alive for over 220 million years. And so we can use their evolution, where they first appear, when they go extinct, when they appear and go extinct, to give you the age of the rocks. So that's our responsibility here. My other team members, they study a different group of microfossils known as worm and infra. They're larger in size, but they're still micro. And then one group, they use it for age control, and my other colleague here, she uses it to help us determine what the conditions are like on the seafloor.
Fantastic. Thank you so much, Shamar. And if you have any questions for Shamar, feel free to drop them in the chat and we'll get back to them in a little bit. And then I'll show you one other lab that this team uses. This is their wet lab. So she was mentioning those smear slides and things. There's a lot of preparation that has to be done when they pull a sample out to get it ready for the microscope. So we actually have to clean it. Yes, they actually rinse it off in the sink to start out. And then after they're wet, they need to be dried off. We actually have like a warm oven here that's able to do that. We have a UV light that's able to cure some of the glues and things like that to prep some of those slides, as well as a shaker table over here to help agitate any liquids, move them around, and again, wash off some of those samples. So this is when they spend a lot of their time prepping it, and then they can go look at it under the microscopes. All right, and now we're gonna head downstairs. We got one more lab to take a look at, and I'll give you a quick peek at our mess hall as well, so you can see where we eat. All right, and I'm gonna be going into the staircase here. We go up and down a lot of stairs on the ship because it's kind of hard to get straight across the ship for like safety and flood prevention reasons. You have to go like up and over barriers. So all the time we're going up and up and up, down, down, down. And because of that, we put a lot of decorations in our staircase. So this is our pet wall. So we're out here for 2 months straight. So we like to have a little reminder of home. And so these are some of the pets for some of the scientists on the ship. These are my cats, Eddie and Olive, right there. Erica. And so then the other main decoration we have are these logos on the wall. So I mentioned we're Expedition 401. there have been a lot of expeditions to come before us. And so every expedition gets to design their own t-shirt logo. And then we have it like during the expedition and then have it printed on at the end. So ours isn't up here yet. We still have a few weeks left in our expedition. But these actually go back all the way to the 80s because there was actually another ship before us called the Glomar Challenger that these are from as well. So they continue to go down the staircase even further. So it's a nice little reminder of our history and all of the science that's come before us too. All right. We're gonna head in. Talk to some of our chemists. And you're gonna recognize one of these people that you just saw upstairs with a microscope, and somehow she ran down here just for you all to come give you a demo down in the Geoca lab. They're waiting. So this is Erica. She's gonna show you around some of what she does.
Inorganic geochemist, and my job is getting water from the mud samples. I use this big machine to get the water samples called squeezer. We put the mud samples into this heavy steel syringe and press like this and get the water like by using this
Syringe, yeah.
syringe case. And after squeezing, we get steel samples like this. Yes, we call it squeeze cake.
Yeah, not as yummy as a cake as, you know, maybe we'll see down in the mess hall in a minute, but yeah.
After getting the water sample, we measure the pH and salinity using this machine. We can get the history of water. I mean, what kind of change experience the water is by measurement.
Very cool. That's awesome. And do you want to show us the gas measurement too? There's one other side of the lab, which this isn't what Erica does, but gets to see it happen all the time.
Laboratory works for the safety check of the joint rig. We get the sample like this, and we get the gas from this bin and put into this machine called the gas chromatograph. And we check the gas content, and we check the there is no dangerous gas.
Very cool. So they're help keeping us safe. We appreciate that. So far, all so good. Get some applause. Awesome. Thank you so much, Eric. I appreciate it. Woo. All right. And now we'll take a quick peek downstairs at the mess hall, and then I think it'll be time for some questions. All right. You let Shamar know if you get it down. Cool. So we're down one more floor for the mess hall. We have each of our shifts. So we work 12 hours a day, each of us. I work noon to midnight. And so that means I get 3 meals a day down here and 2 cooking breaks, which are very important. And so I think we have a cooking break happening now. So we might see some people's snacks, including, this is our ice cream machine, one of our hot commodities down here. Yes, we're allowed to get ice cream anytime we want, as well as our coffee machine next door. You'll see we have some soda machines and some other snacks over here as well, which I know they light up very well in our cabinet here too. So then during our meal times, it's a very, very busy place. Hop in, everyone's coming to get their food. All right, and with that, we're gonna head back up, and I think we're gonna take some questions. So if you have any, feel free to drop them in the chat, and I'm excited to answer them.
Can we, can I say, ask a few questions audibly also? Is that okay, Erin?
Yeah, absolutely.
Okay.
And I'm gonna go ahead and set up in the conference room real quick, and then I'll take this.
Sounds great. Thank you. This is amazing.
Perfect. So yeah, this is our conference room where we also, importantly, we've been out here for Christmas and New Year's as well. So we had our talent show and our Christmas party in here. So we do have our sign for JR's Got Talent still up from New Year's and a little 2024 decoration. So all right. And then I think Erica's gonna send Shamar down, but in the meantime, I can take a couple questions.
Erin, we were just kind of chatting amongst ourselves. I got a few direct messages about how this is for most of us our first time being exposed to having any exposure to this kind of science live, for sure. It's absolutely amazing to see all of the work that goes into what you do. First, I'd like to ask, what was the onboarding process like? Pardon the pun, to get used to life on the ship. What kind of training is involved before you set sail?
Yeah, you can go first. What training did you do?
Let's see. So I didn't need training per se, because my job on the ship just really entails using the microscope. And that's my job that I do back at school. Unlike other people that run machinery, then they had to learn that. So I didn't have to worry necessarily about tech. The only thing that we had to learn was to use a scanning electron microscope, which we didn't necessarily need, but we studied real small things, 100th size of a strand of hair for me. And then for him, it's a bit bigger, but still a microfossil. So that's really the only thing where we had to get trained to use it. And then we all have our preferences for microscopes. So we chose the microscope we want. We have a big room filled with microscopes, and said, all right, can you fix it? This is my preference. So that was really the limit of our training, and getting trained to use the camera software, for example.
And this is Udara, who's joining us as well, for happy to answer your questions too. And I'll just mention from training from our aspect, I did go to College Station in Texas to get some training on the ship and things like that. So we went to like a 3-day training just to kind of get the rundown on, since don't have PhDs in geology like many of the people on the ship do, some of the technology and things like that. And then we also, a lot of us went to Bristol in the UK to kind of meet as a group beforehand and plan out some of our science goals, but not necessarily training, but planning for the mission.
And all of us had orientation, a lot. It was pretty intense though, even though, we had 5 days of transit time, we had.
Yeah, so it was on the ship, but but that was important.
What did the orientation on the ship entail?
So we had to do safety training, for example. We had a captain come in to talk to us. We had some of the techs come in to talk to us because we have to wear PPE.
They saw me wearing
her hat, for example, and her goggles. And so we have to wear closed-toed shoes all the time, which is unfortunate because I have my Birkenstocks I like to wear. But even when you're not out on the platform where they're actively drilling, you still have to wear closed-toed shoes. We also learn what to do in the case. The lab inductions. Oh, the lab inductions, yes. And then what to do in the event, all the phone numbers, right? What we do in the event of an emergency. We went to lab, we did lifeboat training.
Yes.
Or
they saw some of the lifeboats outside.
And we had to sit in there. It was kind of,
it's cramped.
Yeah, cramped in there, and but can hold 70 people. And so that was one of the things we did as well.
And there's this constant smell of diesel.
That will.
So it's hard to breathe.
Yes, and some people will throw up. That's the experience, and so you're cramped in the space, and you can't escape because you're escaping the boat.
So hopefully we don't have to use those, but we now know what to expect.
Yeah.
So.
That's absolutely incredible. I can imagine that, of course, safety is the top priority for everyone, because before you can do any science, you have to be safe. And so you have the scientists and the crew that rotates throughout the expedition, but is the crew that actually runs the ship, do they stay the same throughout several expeditions? Like the captain?
Yeah. Yes.
No, I think no.
They do have, so they'll do shifts where you might be 2 months on, 2 months off. 4
Yes.
months on, 4 months off. But many of the people here have been sailing for a long time, but in rotation.
Yeah, they have like an AB or ABC schedule, so they don't have to be gone all the time from their families, but they're able to have a rotation like that.
But they get paid double the amount when they're sailing.
Yes. So yeah, when you're sailing, you get that bonus for being away from home.
Definitely makes a big difference. Those of you who are in the chat with us, drop your questions in the chat. You can send them to me, but you can also feel free to just post them and I'll read them out. And so earlier I had a direct message about the qualifications to be a part of this crew. On the webpage, we can see that there's several positions like the onboard outreach officer and other roles that we can apply for. What's that process like? And for people who are interested, maybe, students who are in community college or starting at university, and maybe they're going to be off for the summer or they're planning their next summer or fall. If they're interested in participating in this amazing adventure and experience, what do they need to consider before applying?
Yeah, well, first of all, I'll mention some of the opportunities for students that are actually coming up are the School of Rock opportunities. So there's during transits, students are able to come on board and get a shorter experience. You don't have to commit 2 months of your time. And I believe there's one more of those that will be open. Sadly, the JOIDES resolution after Expedition 403 will be ending. There hopefully will be some additional thing to come on after that. But right now it is uncertain. There are other ships around the world I will mention that do have the same similar opportunities in Europe and Japan and China and things like that. So those are the opportunities to look for the future right now.
This is because the National Science Foundation, they have decided not to fund the ship beyond 2024.
Mhm.
So there'll be just 2 more expeditions.
Yeah,
And that's why they are opening these opportunities for students during transits.
Yeah.
And
But hopefully there'll be something new in the future to come. But in the meantime, what are the names of the other ships around the world that they
Chikyu.
stick here in Japan.
Yeah, and I don't know the other one. I know of Chikyu. So they're still actively drilling. They do really deep drilling as well. It's very, I feel like tectonics focus in a sense. And so they focus on volcanics.
And I'm pretty sure there are several ships in Woods Hole.
Yes. Yeah.
Also
Massachusetts.
Scripps Institute.
Yeah.
They do cruises.
And then I know that there's I don't know, I can't say too much about where they are now, but recently there was a call put out asking about ideas for drilling projects because it seems as if they might try to commission other ships in the interim.
Yeah.
And
so if you're interested, keep an eye out for those calls to sail. It's kind of what they're usually called. So you can sail as a student getting a graduate degree. You can be a doctoral researcher. You can be a later in career. There's a lot of opportunities at different stages of your career. Yes.
Amazing. This is so fantastic. And thank you for specifically mentioning the School of Rock, because I did see that, and that was actually part of my motivation for asking that question. Hoping that young people will see this opportunity and be excited to apply, just like I would certainly be. Okay, so we have a few questions from others who are joining us today. Can you explain a bit about the salt giant and the research significance?
Yeah, the salt giant. Who wants to take that? Go for it, Shamar.
Okay, so this was once the largest lake, or one of the largest lakes in the world. So essentially what happened is that the Mediterranean Ocean was disconnected from the Atlantic Ocean and other oceans. There were no open communication, as they call it, because this was an interval of time. So there are many things at play here, where we have what we call tectonics. So here we have the opening of the strait. We actually went through the strait today, the Gibraltar Strait, and so we could see Morocco and Spain just right here. So you have opening because of the tectonics and the continents are moving. And so at one point, then it became what we call an evaporitic basin. So evaporites are things like your table salt, for example. And because it was disconnected and really high temperatures during this time, it drew down essentially because it dried out. I don't know if anyone has ever done that experiment where you put salt in, dissolve it in water and you put it outside and leave it, and then if that eventually the salt will precipitate back out after water evaporates. So that's essentially what happened. And so this plays a big role in understanding our ocean circulation as a whole, because even though it's just the Mediterranean, ocean bodies are connected. So for example, we have the Gulf Stream. So we have the Gulf of Mexico that brings warm water to the North Pole. Okay. And then here we now have sinking of colder water, and that actually helps to heat Europe. And so this plays a role, or the water mass plays a role in terms of how our entire ocean circulation.
Yeah.
And so we want to understand the timing of that connection and also disconnection as well, because it impacts our world's climate.
Yeah.
Absolutely. And so you said something about, you said water mass? The mass of the
So
water?
different water masses.
Different
So,
water
I mean,
mass.
like, yeah,
It's because so the waters with different densities, they don't mix. Same as oil will not mix with water. So they are different water masses. And they like behave differently, those, so that they can sink
yes.
underneath.
So older, colder water and denser water will sink, and your warmer water will float. And so Antarctica, because it's cold there, Antarctica has a deep water mass. And then our surface water here with the Gulf Stream, because heat's coming up and being brought up along the northeastern seaboard of America, that's a surface current because warm air rises.
Oh, okay. That thank you for that explanation. I had never even heard of water mass before. I didn't realize.
Sorry, you should explain that.
That's
I knew there were different, isotopes of water, but that's different than different water masses. Wow. Okay, thank you for that question, Annalise. And we have from Leah. Leah says, because the JOIDES resolution is going to be retired soon, will the drilling gear be transferred onto other ships?
So the ship is being retired.
Yeah,
Or-
but the ship will be available for
Yeah.
commercial purposes
Commercial,
only.
yeah.
Yeah, the ship will still exist. The ship is actually leased out by the National Science Foundation and the people on board, so it's owned by another company. So the ship will still be around. Don't know exactly what its future holds. It's a bit of uncertainty right now, but there will still be ocean drilling happening. There might be a little break for the JOIDES for a bit. We'll see.
So CM is CM the company? Yeah.
Yeah.
Okay, well that's good to know that it'll still be around and in use, doing hopefully something similar, some very similar science. And so I know we have maybe about 5 minutes left. If I would really appreciate if you would each maybe share with us some of the experiences that you've gained that have really made the voyage so far be worthwhile and fulfilling from a scientific standpoint.
I can go if you want.
Okay, yeah, of course.
Well, I'll say, I think literally, I know we mentioned it, Colette, but today it was like the highlight for almost everyone on the ship. We're on the ship that works noon to midnight. We all got up early because we could start to see land around 6:30, 7 a.m. So we've all been up for a little while. I'll tell you a secret. So we might be a little tired.
I took a nap.
But Shmar got a nap. She was smart. But we got to see pilot whales out in front of the ship, like in the waves. We had to see both continents. It was very cool to have like everyone from both ships there. It was a very cool moment. And also we get to go into the Mediterranean through this like gateway, which is a lot of like what we're studying for this expedition.
Yeah.
So it was a very cool moment. I don't know if there's any other highlights you want to share too.
For me, it's like meeting all the people. For example, Shamar is the only person I know from Jamaica. And so, for example, Erin worked for NASA. So, like getting to know all the people, and you get to learn a lot from lot with their different expertise. So that's my experience.
Anything else from you, Shimon?
Yeah, that's definitely one of the things. You get to be on this expedition with people from so many backgrounds and countries because it's a joint effort between 21 countries. And so it's, you know, cultural differences and learn about each other's culture. These are meals that you're sharing with people. Remember, you're spending all the 12 hours of your day, and also more than 12 hours of your day because we overlap at meals and everything. And so, and just learn about what other people do. You know, I can hop over to someone's lab and say, oh, hey, what's going on? Oh, let me say to the core, even though I'm on a microscope. And there's a lot of, I would say, interdisciplinary work. So even though I work on a microscope here, a lot of my work entails, or many of us will entail integrating all our data together. Yeah.
Incredible. It sounds like the experience of a lifetime. Yeah, I know, as you all were saying, many people do this regularly. They may take a few months break, but this is kind of their life. Life on the ocean. This is so incredible. And so in these last, I think, 2.5 minutes, Erin, I know when we have 2 more sessions coming up with you all, and I'm so grateful for that, because I feel like I learned so much this session that I need to stop, listen to everything again, and come up and have questions. I have so many questions, but it was so engaging that I didn't even have time to write them down. So I'll be prepared with those for next time for sure. And so we got to go and see many of the labs where you all eat. What about your quarters, your dormitories? Are those? Do you have shared spaces, or do you,
Yeah, good
what's that
question.
like?
Yeah, well, so the only reason I don't take you there on tour is because we can't talk in them. So there's, because since we're on different shifts, there's people sleeping always in there at all times. But yeah, it's a bunk bed shared space. We share with a person who's on the opposite shift from us, so we do get that space to ourselves for 12 hours a day, which is very good. But yeah, it's a decent space.
Yeah, and not only that, we get a different scientist as well. So, for example, my co-biostratigrapher that works the night shift, we are in rooms beside each other, but our roommates are geochemists. And the geochemists work together because you're already in each other's spaces, because you're going to overlap by 2 or 3 hours anyway. So I think that's why you want to, you know, give you some space between your lab mates.
Yeah.
Absolutely.
But it's really nice.
Yeah.
Laundry.
Oh yeah. You go ahead.
Oh, right. So you put your clothes outside, and by the time you get back, your laundry is folded nicely.
By the time you wake up,
By the time you wake up.
So,
or get back to your room.
Since we're working so much, we luckily have people to support the other things that we don't have time for, since we're working all that time. It's very nice.
It's great stuff. Great stuff here.
That's amazing, the support that you all have to enable the research that you all do on board the JOIDES Resolution. Well, in this last minute, I would like to turn it over to Erin and you all for any final words before we see you in our next session in about a week.
Yeah, well, just thanks for joining us. Appreciate it. And next time we'll get scientists from some of the other areas, because we're going to do 2 others and do some Q&As with scientists with some other expertises. So even if you were here for this one, you might see some similar stuff, but hopefully we'll get you some other scientists to be able to talk to, ask some other questions. And yeah, really appreciate you coming along on the journey with us.
We are grateful
ahead.
that
So I
you
just
allowed us to shadow you. Yes, please.
Yeah, of course.
Don't be discouraged about the ship or us no longer commissioning the ship. There's still going to be many opportunities in the next 5 years that will be funded. So even if you're not on the ship per se, so for example, how I got into this or applying for ILDP, I started working on sediments because you do have cores that are stored. We don't just throw them away after the expedition. And so you have cores starting in the 60s when the expedition started, still stored in these huge facilities in Germany, Kochi, Japan, and also in Texas by Texas A&M. And so I did research on ILDP material for 10 years. I started in 2011, 2010. And then it's kind of a full circle moment.
Yeah, the course that we're pulling, you can study decades later. So we're hoping we're providing material for science research for
Yeah.
many, many years.
We can't solve it all. There's always more work to be done.
Yeah, so you could be that person to do it.
That's amazing. That is absolutely phenomenal. Well, thank you all so much for allowing us to join you for an hour to see what it's like to live and work aboard an active research vessel, the JOIDES Resolution. Thank you all for joining us in the chat. Anand and Annalise, Leah, Rob, and I believe Shalom. We're so grateful to have you all. No worries, Rob. No worries that you're late. We have 2 more sessions coming up. And so I certainly hope to see you there. We wish you all a great rest of your evening there, and I hope you get a good, nice rest. Thank you so much again, everyone, but especially Erin. You have been absolutely fantastic. We'll see you again in about a week.
Thank you so
Thank you. Take care.
Bye.
Aloha.